Good afternoon, guys, and today we're meeting with you all with another video, and our topic is covalent bond. So, in our previous video, we have watched that there are two kinds of bondings, and the first one was we already have discussed that, and that was the ionic, and it is completed in our previous video. So now we're starting with the covalent bond. So what is the definition for covalent bond? So it is the sharing of electrons between atoms. So we can tell it in a more detailed way: sharing of electrons, the valency shell electrons, or the lone unpaired electrons in the valency shell with another atom is called covalent bond, right? So for example, we can see the first example that we're going to consider is hydrogen. So it has the atomic number 1. So what does that mean? It has atomic number is equal to the number of protons equal 1 and electron is equal to 1. So we draw like this. It is hydrogen in its nucleus, so the orbit surrounding it has an electron. So if you take another hydrogen atom, it will have an unpaired electron. So these two share with each other. So they form like this, right? So I only draw the outermost orbit, that is the valency shell, to show you that both the electrons share. So now this hydrogen has 2 electrons in its outermost shell, and at the same time this one is also having 2 electrons in the outermost shell. So that means by sharing electrons they attain a complete orbital level, right? So it gives them more stability. So our second example is going to be chlorine. So that's how H2 gas, 2 hydrogen atoms forms H2 gas, and it is formed by sharing of electrons. Now we'll see Cl2 is also like that. So what is the atomic number of chlorine? It is 17. So 2 and 8 and so on. So how did we divide that? The first orbit can only hold up to 2, second 8, and third can hold up to 8, but here there is only 7, so we write here 7. So let's consider it. Chlorine. So 2 in its first shell and 8 in the second. So it's 10. Now we have 7 here. 6 and 7. So 1 is unpaired. So likewise, if you take another chlorine, the same thing with it. 2. 8 and 10 here. And the final orbit, that is called the valency shell, is having a single electron which is unpaired. There's 7 electrons and 1 unpaired, and here also 1 unpaired, so they both share each other. So when you're drawing the diagram, you only draw the outermost layer. So they share. So there was already 6 paired electrons, so there were 3 pairs, so we call it altogether 6 plus a single one. So another single one, they share, and so now both has got 8. So that means they reached the stable level. Likewise, you can try for the other gases. Right now, I'm going to give you another example of a bit. We're going to go like something like hydrogen HCl, hydrogen chloride. So you already know the outermost one I'm drawing now. H is only having one electron, and the outermost of the chlorine there was 6, right, plus a single one, 3 paired and a single one, and the hydrogen had only one, so it will share, and now it has got 8 and this has got 2, so they are stable. So likewise you can try for the other ones also.